Everybody say good morning. Or just sit there and be quiet awkwardly. Okay. Guys, we're starting chapter 8. We're going to add and subtract polynomials. Kevin, say polynomial.
Poo-poo.
Don't say poo-poo. Say polynomial.
Leomial.
Yeah, he's just being strange. Okay. We're going to add and subtract polynomials today, but let's talk a little bit about polynomials. A polynomial.
I don't like
Don't have a bad attitude already against it, Kev. A polynomial is a monomial, or the sum of monomials. Okay? What does the prefix poly mean?
more than one.
More than one, or many. I've heard both definitions. Many or more than one. What does the prefix mono mean? One.
And
So if we have one piece or one term, it's a monomial. If we have more than one term, okay, it's then considered a polynomial. All right. Each term of a polynomial, each piece of a polynomial is called a monomial.
That's what I said.
Guys, take a risk. It's okay to be wrong. We'll fix it. All right. Each term of any polynomial, guys, is considered a monomial. All right. Some of the specific ones. If you have a two-term polynomial, what's that thing called? No.
that's
Good guess. No, you guys know it. We've mentioned it before. A binomial. Okay? A two-term polynomial is considered a binomial because the prefix bi means two.
trinomial.
Okay? And then what's a three-term polynomial called? Trinomial. Prefix tri means three. So we're going to
Yahoo!
bless you, Mr. Kevin.
Tricycle.
Tricycle. The tripod.
Guys,
Triangle.
now click an R.
Triangle.
Triangle. Very good.
What about a biangle? Oh yeah, that's a line.
The minimum size that a figure can have is 3. You can't have a two-sided figure. It's not closed then. That's why there's no bi-angles.
Unless it's a circle.
Okay, you bisect an angle, which you'll do in high school.
Did you like it?
Right.
Dissect.
As long as you curve one, you can do it. But how about straight line?
Triathlon.
All right. A triathlon, very good. Or a I think there's even biathlons.
Just two sports.
Where you do two things. I don't know what two things you do in a biathlon.
Swimming and
Running.
Running, and so did they get rid of the biking? Maybe.
Or biking and running.
Oh, okay.
Definitely running. I don't know what the other one is. That's a biathlon.
Maybe a biathlon's like a
What about a mono
quad
A marathon? How about a marathon, Alex? Right?
Well, yeah, but I was just trying monoathlon.
Polyathlon.
A Kevin.
Quadriathlon.
Okay, I appreciate all the prefix work here we're doing, but let's get back at it. All right, one of the big important things today, guys, is to find the degree of a monomial. Once we do in a couple examples, you guys hopefully will see how to figure out the degree. It's really not that bad. The degree of a monomial is the sum of the exponents of all its variables. You understand that? There's like 3 different things you got to really think about. Sum means to add exponents.
Multiply
Well, no, those little numbers that are above the
by itself.
exponents, right? And then of all its variables. Just the variables, not the coefficients, not the constants. Okay? And we're going to address that right now. A non-zero constant term has a degree of 0. And the number 0 actually has no degree. So, any constants, like, Briggs, give me your favorite number between 20 and 30. 21. The degree of 21 is 0. It's a number. Any constant has a degree of 0. We're worried about the variables and the sum of the exponents of those variables. Now, the degree of a polynomial is a little different. The degree of a polynomial is the greatest degree of any term in the polynomial. So what you got to do for a polynomial is find the degree of each monomial. And we'll write those down. And then whichever one's the biggest, well, that's the degree of the whole polynomial. All right, next thing. It would be wise for you guys to study and know that chart. Okay? And again, we really haven't even done any degree problems yet. But if the degree is 0, it's a constant. The number 21 Everybody knows what 21 is. It's an amount. Okay, you know what it is? The degree is 0. It's constantly 21. If the degree is 1, it's considered linear. 2 is called a quadratic, which is a little weird because everything's quad means 4. But the degree is 2, it's quadratic. 3 makes sense, it's cubic. And then 4 and 5, guys, really not that important. But just be aware of them. 4 is quartic, 5 is quintic. And then if it gets 6 or more degree, you just call it a 6th degree polynomial, 7th degree polynomial, 8th degree polynomial, and so on and so forth. Pretty simple after 5. All right, here's what you guys are going to be doing for your homework. But again, guys, look and study that chart a little bit. All right, don't blurt it out if you know the answer. That's what I want everybody to think. State the degree of each monomial. 12x, the first one. Refresh. The degree of a monomial is the sum of the exponents of all the variables. Sum of the exponents. Don't say it out loud. What's the degree of 12x? Raise your hand if you think you know it. Take a risk. It's okay to be wrong. Briggs. But what's the degree? It is linear. So what's the degree, guys, is 1. You name it with a 1, with a number. Because, guys, the 12 means nothing.
Yeah, I was just gonna say
What's the exponent on the x?
1.
A 1. The degree is 1.
So even if there were,
We'll get to them. Hold it, Kev. Hold that thought. I like it.
What's the word linear?
No, you don't have to write that. Just state the degree. We're just if this thing is linear, believe it or not, but we'll deal with that. Because think about it, if you graph 12x, it would be a line. That's why they call it linear. All right, how about this letter B? What's the degree of a to the 8th power? Raise your hand when you got it. Nico. 8. Agreed.
Good work.
Okay, agreed. Pretty simple. Okay, it does get tricky. I shouldn't say pretty simple. It does get tricky. How about C? Negative 17. What's the degree of that thing? Just think. Ms. Biaggi, what do you think? 0.
0.
The degree is 0. All right. Here's D is our first one with multiple variables. The sum of all the exponents on all the variables only. What's the degree of 3, x to the 4th, y, z to the 5th? Take a risk. Sean.
9.
One more.
10. Oh, there's a
Why 10?
one on the y. And 3.
On the what?
The y.
Exactly. There's a little sneaky 1, guys, on that y. So the degree, guys, believe it or not, is 10. How about the last one there? What's the degree of letter E? Henry, what do you think?
7.
7.
So it can never be negative.
It can never be negative. I don't think
Or
it can.
0.
I don't think it can be 0.
that would mean you
It can be
have-
0.
It would be 0.
That would mean you have to have negative exponents, but
Which-
you can't.
But you can have negative exponents, which means
It's a fraction.
it's not a polynomial, which we're going to get to in a second. All right. Here's one part of all this. What this means. Just listen and learn something. No one ever told me this, but I'm going to tell you guys this. I always tell my kids this, and it always pays off down the stretch for them. Guys, guess what the degree means? The degree means how many solutions there are if you solve it. For example, 12x. If you set it, don't write this down, just watch. If you set it equal to 0, guess how many solutions there are? 1. Guess what that solution is? What times 12 makes 0?
X equals 0.
0.
12 times what makes 0, Sean?
Exactly, x would equal 0.
X would equal 0. How many solutions is that? 1. Guys, a to the 8th power, if you solve that, there would be 8 solutions.
But what if you
Believe me.
12
Hey, negative 17, that's the only, there's no solutions to that because there's no variable. And you guys would never solve anything like D or E, but if you did, there'd be 10 and 7 solutions to it. Also, what that means, the solutions are, if you graph it on a coordinate system, the solutions are where it crosses the x-axis, not the y. Y doesn't matter, the x-axis. So believe it or not, guys, if we graphed a to the 8th, it would go like this. 1, 2, 3, 4, 5, 6, 7, 8. It would cross the x-axis 8 times. And the numbers where it crossed would be the solutions. Okay? So that's going to make sense when we do chapter 9 and we start graphing quadratics, because the number of solutions is the degree. All right.
So now this is the hard stuff.
No, that's not too bad. All right, let's state the degree of the polynomials. Remember the degree of a polynomial? Go up a little bit. The degree of a polynomial is the greatest degree of any term in the polynomial, which means you've got to find the degree of each monomial or each piece, and then whichever one's the biggest, that's the degree of the whole thing.
But then if it's multiplied like d, then you just.
Oh, we'll get there. So, what's the degree of 8x cubed? What's the degree of 3x squared? X? 5? It's in standard form. How convenient. What's the greatest degree of any of its pieces?
3.
Guess what the degree of the whole polynomial is? 3.
There's no negative.
What's the logical question the kid has right at this point that they asked last period? No.
That'd be
Why is
Why
it
would
zero?
you-
What if there's a tie?
What's that
What if
number?
there's a tie?
It's that number.
Yeah, you use that one. Okay, if there's a tie, and that's the greatest one. Like if they said, what if there's a 4, a degree of one part is 4, and another part is 4, it's a tie, you would use that.
Oh, I wouldn't.
Okay.
do that.
Exactly. But some people want to add them together. All right, find the degree of each piece there. I'll give you a tough one. Find the degree of each piece, write the number underneath each piece, and then whatever's the greatest one, take it. Nico, part 1,
It's 5.
5. Albano, part 2, 8. Excellent. Sarah B, part 3. 6. Oh, I was looking at Madeline. Sorry, 6. And Madeline, last part. 2. Quinlivan, what's the degree of the whole thing? 8, the biggest ones.
5,862.
Well, I gotta get. All right. I gotta come up with a trick for me to remember this now. All right, I got a trick. All right. So the degree of the whole thing there is 8. All right, not too bad. Okay, next you might have to flip back and forth to talk about the degree and/or if it's a monomial, binomial, or trinomial. Determine whether each expression is a polynomial. So you can write yes or no in that second column there. If it's a polynomial, find the degree. Put the degree in the third column. And then decide if it's monomial, a binomial, or a trinomial in that last column. Okay? All right. 4y minus 5x. Wow. Is that a polynomial?
Yes.
Yeah, sure it is. Okay? What's the degree of that polynomial? Raise your hand, don't blurt it out. What's the degree? Kevin.
3.
It is not 3.
2.
Remember, the degree of a polynomial is the greatest.
Oh, yeah.
So what is it?
1.
Nope, there's one that's higher. What's the degree of the first part?
You add the 2 on the other side.
Let me explain it to him, he's
Oh, it's
confused.
2.
What's the degree of the first part?
1.
1.
And then the next one's 2.
The next one's 2, because 1 plus 1 is 2. So what's the degree of the whole thing, Kev? 2. The highest one. Not all of them. Don't add them all together. And then Kev, is it a monomial, binomial, or trinomial?
5.
Binomial. 2 pieces. Okay? Now, last period, totally confused about this next part. Is negative 8.5 a polynomial?
No.
No.
No, it is. Well, is it a monomial? The question is always, what is a monomial? Okay? A monomial, we actually defined it last chapter, is a number, a variable, or a product of numbers and variables. So, whoa, that was crazy. So, a number, guys, is a monomial. and a monomial is also a polynomial. So believe it or not, any number, any constant, you say yes, it is a polynomial. I'll tell you what's not a monomial in a minute. Sean, good question. Hold that thought. Go ahead.
I was going to say it's still a degree of 0.
Right, that's my next question. What's the degree, Sean?
0.
0. The degree is 0. And then, Sean, is it monomial, binomial, or trinomial?
Monomial.
Monomial. Very good. Okay. The next one's tricky. I'll give you guys a big hint. You must
Add like
CLT.
combine
Yeah,
like a
numbers. How many people remember what CLT stands for? Besides Olson. Combine like terms.
Canadian bacon, lettuce, tomato.
Dude, it's too close to lunch to be talking like that, all right? Don't get hungry.
I'm hungry.
All right. Mr. Olson, what is 2x plus 4x?
Oh, you have to do all of it?
No, add those two pieces together.
2.
No. What's 2x plus 4x? Combine them,
Oh, you have
CLT.
to do that?
Yeah.
6x.
Yes. Well, no, it's not squared, it's just 6x minus 7. So believe it or not, guys, that third one down is really this, what I wrote in blue. You have to combine your like terms. Mr. Henry, is it a polynomial?
Yes.
Yes. What's the degree?
4.
4. Very good. And is it a monomial, binomial, or trinomial?
Binomial.
How many pieces does it have?
Trinomial.
3 pieces, it's a trinomial.
Wait, why don't we do that before though?
Ah, great question.
Because we get the same answer, but why?
Well, tell me one where we did not combine like terms.
The A was 8x to the third power minus 3x to the second power plus x.
Genius, Sean. Back the train up, people.
It still got the same answer no matter what though,
You talking about example 2, letter A?
but yeah.
All right. Can you
They're
add any?
different.
Can you add any of those together?
No.
Well, or subtract them.
Yeah.
Okay.
No.
What do you think? We're gonna fix this. What's 8x cubed minus 3x squared?
5x to the first power, or 5x.
Can't do it.
Not like terms.
It's 8x cubed minus 3x squared.
Sean, to be like terms, the
Oh,
variables and the exponents have to be the same,
okay.
not just the variables. So you can't combine anything there. Why could we combine them on this third one down here?
Then
Because they have the same exponent, right? You can't combine x to the fourths with x's. They're
so
not like.
on the first
Yeah,
one
what
up
about
there,
the first one?
it's because of the constant.
No, it's because the first part doesn't have an x. The second part does. 4y minus 5xy, those aren't like terms. Right? Okay. All right, and then here's one, guys. What do you guys see wrong with that fourth one down? Negative exponent. That makes it not a polynomial because it becomes 8 over g cubed, which we said a monomial. You can't have a variable in the denominator. Does anybody know why you can't have that variable there in the denominator?
Because it's like a 0.
Because if g's 0, all of a sudden this thing becomes undefined. Okay? It becomes undefined. You can't have that. And then no degree, no name. Nico.
Is that the only time it's a nub?
Yeah.
When it has negative?
When it has variables in the bottom. Because we could have written something like 3x over y. There's no negatives there, but there's a variable in the denominator which you can't have. So no variables in the bottom. That's basically, and negatives, exponents make variables in the bottom. Agree?
Yeah.
So that's why. Good question. All right, next part. We're going to talk about standard form. So I tried to space these blanks out well for you guys. The standard form of a polynomial. Write those 5 words, guys, in those 5 blanks. Standard form of a polynomial. And you guys are totally going to get this. It's going to be pretty good. Has the terms in order from least from greatest to least degree. Okay? So you got to put the greatest degree piece first, all the way down to the least degree last.
Oh, like the one that's Sean example 3210.
Exactly. That's called descending. How do you spell descending?
DESCEN.
Okay, I did spell right. Descending. They call this also descending order. What does the word descending mean to you people? Go down. When a plane descends, when it lands. Does everybody agree with that? Way up in the sky and it's going to land, it's descending, it's going down. Your job is to put your polynomials in descending order of degree. Okay? And then for some reason, they're going to make us identify the leading coefficient. That'll be about the easiest question you ever answer in your entire life. All right, let's do this. 3x squared plus 5x to the fourth plus 1 minus 2x. Which monomial of those four has the biggest degree? 5x to the fourth, right? That goes first. Cross it off. What's the next biggest degree after that one? Kev,
3x squared.
give me a sign in between that goes in front of that would be in between your two pieces.
Addition.
Addition, right? Because it's positive. So, plus 3x squared. Keep going, Kev.
Minus 2x.
Minus 2x
Plus 1.
plus 1. Sodaro, can you add any of those together?
No.
No. Why not?
Different exponents.
Yeah, they're not like terms. Guys, look at that. That's descending order. Look, does that make sense? Okay, $10,000 question of the day. Why would I expect you to put them in standard form, or other math teachers, or your book? Why do we have to put them in standard form? Last period had no problem answering this question. Why do you have to put them in standard form? Right, because it says, nope, that's a good answer.
So you can identify the leading coefficient.
Ooh, I like that answer
I was
too.
gonna say that, but
That's not it. That's not the reason though. But, guys,
Does it find the highest degree?
Then you can graph
that's
it.
even smart stuff, Nico. But that's not the reason.
You can graph it.
No. Guys, what if we all put them in standard form on answers?
Easy to grade.
It'd all be in
Right. Expand on that, Nico. What are our answers all going to look like?
The same.
Guys, all of our answers are going to be the same.
unless you get it wrong.
Unless you get it wrong, very good point. If we do it right, our answers are all going to be in standard. Our answers are all going to look the same. So when I go to grade,
Oh, yeah.
when I go to grade something, everybody's going to have that answer instead of just these four random monomials jumbled all up, which take me forever to grade, or math teacher. So it's just a common thing to do is put them in standard form. Now, second part of the, we called it the LC last period. What's the leading coefficient?
7y.
The problem we're on now.
4.
What's the leading coefficient, guys? 5. So now, how'd you know that?
Because coefficient is one of the highest.
Yeah, it's the leading coefficient. Your leading thing is your first thing. The leader, it's the first.
It's
The
not
beginning.
exponent.
And remember, what's the coefficient, Al? What's the definition of the word coefficient?
Then the number in front of the variable.
So what's the number in front of the lead? 5. No variables. No exponents. What? The leading coefficient is 5.
Is that just the highest one?
It's not the highest one, it's the leading one. It's just a coincidence, Nico, that the first one happens to be the biggest one. Okay? All right, everybody rearrange these and put them in descending order. Go.
Hold on, I got a question.
Go ahead, McNulty.
Y and 10 are at the same degree.
They're not. The degree of y is 1, the degree of 10 is 0. Agree? Okay. Briggs, whole thing, let's go.
Negative 7y to the fifth, plus 5y to the third, minus 2y to the second, plus y plus 10.
You were the man. Notice, guys, it's in descending order. It's in standard form.
There's another way it could be different.
No.
If it has exponents on one of those,
Well, would you combine them together?
oh,
If they're like terms, you would add them together. Okay? And Quinn Livin, what's the leading coefficient? The leading coefficient is not 5. That would be the last coefficient. -7. Leading is the beginning. Leading. So the LC, guys, is -7.
What's the point of identifying the leading?
That's a great question. I'm not sure where they're going with that, but I've seen books do it before. They're just going to ask you what's the leading coefficient.
What's the first number?
All right,
It's
next.
like-
Here's what you guys are going to... Guys, that was all just terminology. That was all just learning new words, new things going on. What you guys are going to do for your homework, guys, or what we do with polynomials, is we add them together. No crying. There's no crying in algebra. Okay? To add or subtract polynomials, guys, put them into standard form. You're going to do that right off the bat. You'll get good at putting them in standard form.
Not our traditional standard.
It's kind of like the ax plus by equals c, believe it or not. But anyways, and we're going to use what they call column, or we call it column form. Everybody put your arms into a column. Which way do columns run? Are columns this way or this way?
This way.
That's an angle, dude. Columns are straight up and down.
Drunk
Okay? We're going to add them in column form. All right. And they usually put parentheses around the polynomials. Okay?
No.
Basically, guys, this is a lot like CLT, but we're going to do it in column form. Is that first given polynomial in standard form?
Yeah.
Yes, clearly. So we're going to write it down. I write 3. Such a moron. 5x squared minus 3x plus 4. We're going to add to that in columns the second one, but we're going to rearrange it to be in standard form. Who could put the second one into standard form in about 2 seconds? Give it a shot, Nico.
-3x plus 6x.
Don't say. Make sure you say squared. -3x squared. Say it.
-3x squared plus 6x equals -3.
-3. Guys, when Nico turned that one around and put it in standard form, what happened with our like terms and the column form?
They line up.
They lined up.
They line up.
In a
It
column.
is against the law to put an unlike term underneath something. It's not like it.
Okay.
And I'm going to show you what happens. Some weird stuff
Unless
happens.
you're in Russia.
Anyways, once you put them in standard form, everything lines up. Everybody add your like terms together. Go. So now you're going to answer the question because we got to get you understanding these like terms better.
Alright,
Do it.
we got 2x, to the second column,
Gotcha?
minus 9.
Start thinking. We're adding. -3x plus 6x.
Oh, I'm minus it.
Oh, yeah, it's positive 6x.
Okay. Plus 3x
Plus 3x. Very good.
plus 1.
Plus 1. And can you add any of those together, Sean? No.
Oh yeah, you don't subtract your exponents.
Yeah, this is not only multiplying and dividing. We're going to start adding and subtracting exponents on your bases. Okay, that was last chapter. But you need to know last chapter to do what we're going to do here in a couple days. All right, now it gets hard.
They don't have the same thing.
Chupinski, read us the first polynomial that's in parentheses there. How would you say that? Okay, guys, what terms are missing from that first polynomial so that you would have go down by we want to go down by 1 every single time. Does everybody agree there's no y cubes? Right? And there's no y squareds. Okay? You have to put those into your columns as you make up the problem. Here's what I mean by that. Y to the 4th is the greatest degree. Blank. Blank.
So that goes in for y to the third and y to the second.
There's your y to the 3rd and y to the 2nd. You've got to have a column for every degree going down. But we have y's, so I'm going to put a plus 3y. We have constants plus 7.
No, I plus it, it would be negative.
Oh, yeah, you're right. Nice catch. Minus 3y. So blank for the y cubes, blank for the y squareds. There's some y, so I'm going to put them. Now, take the second one and put your like terms in the right columns. Because there's columns for them.
2y to the fourth.
Negative 2y to the 4th. You drag that sign in front of it with it. Negative 2y to the fourth
Plus 2 out of the third.
plus 2y cubed blank. There's no y squareds in the second one either. Plus 2y minus 11. Now we can add them together. Everybody take their time and try to add those two polynomials together. Look at your stuff and make sure your like terms are lined up. If you got y cubes and y to the fourths in the same column, you did it wrong. Anybody think they can do this?
Yeah,
Never end.
I got it.
Go ahead, McNulty.
Negative y to the fourth plus 2y to the third minus y minus 4.
Done.
You don't put a blank?
No, don't put a blank in your answer. It's a good point. Don't put a blank in your answer. That would just look silly if you put a blank in your answer.
I did.
Guys, that's what we're doing. Now, guess when it gets hard?
When you have to subtract.
Subtracting. Why is it hard when we subtract?
But subtracting.
Do we subtract in here? Guys, do we subtract in here?
No, we add the
Right. Don't subtract. Add the opposite.
It is stupid. It should be community. Do not. No.
No
Yeah.
subtracting. Add the opposite. So, because you want to subtract that whole trinomial from that first four-term polynomial, okay? But it gets confusing with the signs and stuff. So basically, it's like distributing a negative 1. Does everybody agree with that? So I see this problem right underneath the, I'm going to go plus, and then I'm going to change all my signs in the second polynomial only, because you're going to distribute a negative 1. 2x cubed minus x squared plus 2, and then I'm going to cross off my original. Because we don't subtract, we add the opposite. Go ahead,
Is
Olson.
there ever, like, 4x to, like, the 9th, and you have to do 9 columns?
I doubt we would get on that hard. But yes, you would have to.
Yeah,
It does take up a lot of
it
space
would
sometimes,
take a
guys.
long time.
All right, let's do this. This first one, we're not missing any pieces. That's good. 4x cubed minus 3x squared plus 6x minus 4 plus, what piece are we missing? Are we going to leave a blank on that second one?
6.
Yeah, it's the x's. There's no x's in there. Okay, there's x cubes and squareds, but not just x's. So I'm going to add to that 2x cubed minus an x squared blank plus 2. Add them up. Add them up. Mr. Aaron?
6x cubed minus 4x squared plus 6x minus 2.
Nice job. And I should have mentioned this as we go through this. Aaron, what's the degree of that polynomial? 3. How many solutions are there if we solved it? 3 solutions. How many times would it hit the x-axis?
3.
3. This would be a great, we will graph this eventually this year, I think. We graph this, it would look like this. Totally cool. It goes. It hits the x-axis 3 times. 1, 2, and 3. Okay? We're going to graph them this year. All right, try that next one. Don't subtract, add the opposite. Plus negative 7 plus y cubed minus 12y. Basically distributing a negative 1 sign. You guys know how to do that. Okay? Standard form, 5y squared plus 8y minus 10. We're not missing any terms there. Oh, jeez.
Yeah, what about the y?
What about the y to the cube? OMG, what are we going to do?
We need a blank.
Yeah, put a blank.
Yeah, you're gonna start with your y cubed in the bottom. You're just gonna make a new column there. Y cubed blank minus 12y minus 7. Because standard form, guys, the biggest degree goes first. You gotta put that y cubed out front. Okay, Miss Madeline, you got an answer?
I got one. Oh, yeah, I got it.
That girl's scared of me.
I got it. Ooh.
Come on.
I got it.
Olsen, say it.
Y cubed plus 5 y to the second power minus 4y minus 17.
Minus 17. Done. Nice job. Madeline, is that what you got for the most part? Confidence? Loud and proud?
We don't have to do the last one if we don't want.
Nope, last one. Let's see if you guys can do it. It's hard. That's why I gave you so much space. In the
Oh,
bottom.
is it? I'll get this thing done.
Here we go. 4a to the 5th
No.
minus 3a cubed.
Need a blank between.
Yeah, you need a blank.
On the squareds, right?
No, between 4a fifth and minus 3.
Oh, I forgot the fourth one. Yes. So I'm going to move that over. I didn't even see that. 4a to the 5th blank 3a cubed blank plus 8a minus 1.
Isn't it negative 3?
Oh, we never changed it to addition. Plus negative 6a to the 5th plus 5a to the 4th minus 3a plus 2a squared minus 9. Cross off the old one. Get in the habit of doing that, guys. Parentheses. So, negative 6a to the 5th plus 5a to the 4th blank plus 2a squared minus 3a minus 9. Anybody think they can do it? You really got to think as you set your stuff up. You know, with the columns.
Alright.
Sonara, you think you got it?
Oh no, I got it.
I got it.
I was still on the second.
All right. Give it a shot, Briggs.
Negative 2a to the 5th plus 5a to the 4th minus 3a to the 3rd plus 2a to the second.
I lost the negative sign there too, guys. Hold on.
Oh, I got it all right.
Minus
Plus.
3a to the 3rd. Very good.
Plus 2a to the second plus 5a minus 10.
It's 5a minus 10. That's a 9 there. Looks like an A. So now, can we add any of those together?
No.
Why not?
Those are not like terms.
They're not like terms. Very good.
You should go a little bit.
The one before this one?
Yeah.
Blue. All right. Welcome to Polynomials, people. Signing off. Everybody say bye.
See ya.
But,